Welcome. Today we are working with function operations. We're also going to be doing composition of functions, and we'll also talk about the domain of functions. Now, these two functions, f of x and g of x, that I've given you here, these happen to be polynomial functions. If you are adding these two polynomial functions, we're talking about adding f of x, x squared plus 9x minus 7, plus g of x, which is 3x squared minus 5x minus 8. So really all I have to do this addition is combine like terms. So the answer to f of x plus g of x is 4x squared plus 4x minus 15. And there's your answer. Now, the domain of this, there are no restrictions here. So the domain is all real numbers. When you multiply 4 times a number, that's a real number, you get a real number. When you raise a real number to a power, in other words, multiply a real number times itself, you get a real number. When you add real numbers and subtract real numbers, you get real numbers. It's a closed system for multiplying, dividing, adding, and subtracting. With the only exception of you can't divide by 0. So, it's at least closed with multiplying, adding, and subtracting. Now let's look at f of x minus g of x. So in this case, f of x, x squared plus 9x minus 7, minus g of x, 3x squared minus 5x minus 8. To do this, I'm going to distribute the negative to the second parenthesis. X squared plus 9x minus 7 minus 3x squared plus 5x plus 8. Now I have to combine like terms. Negative 2x squared, let's see, plus 14x plus 1. There is the value of f of x minus g of x. Now the domain here is a little bit interesting. The domain is all real numbers again. I just want to show you set notation. That would be braces and all x values such that x is an element of the real numbers. And that is a way you can write it. Now, I'm not going to ask you to write it in this way. You can just write domain is all real numbers. That's fine. But this is the way you're likely going to see it in pre-calculus. So x is part of the set, or all x values such that x is an element of the real numbers. Okay. Now, where do you get a restriction? Here is an example of a function that would have a restriction. We know that in the real number system, we're not allowed to square root a negative number. 0 or better, or bigger, I should say, is acceptable. So to find the domain values that are acceptable here, you can either think it out, or you can say the inside of the square root has to be greater than or equal to 0. That would be positive or 0. And to find the values that work that way, solve for x. X has to be greater than or equal to positive 3. Because positive 3 is what makes that 0. So any value greater or equal to 3 will give you a value that you're square rooting that is 0 or bigger. So that would be the domain in this example. Now, if we're talking about multiplying and dividing and the domain of it, please be aware that if you're given h of x and g of x, it's not always listed h then g. Sometimes it's g then h, or a then b. Sometimes it's b then a. So pay attention to what is actually given to you. Don't just assume because it's in that order above, it's going to be in that order down here. All right, so h, 3x, times g of x, 12x to the fourth. This is equal to, these two multiplied together, 36x to the fifth. And again, this is all real numbers. I'd even accept you to write it shorthand like that. In the next example, h is being divided by g. h, 3x, is being divided by g, 12x to the fourth. This, when we reduce it, is 1, the 3 and the 12 cancel to a 4 on the bottom and a 1 on top. X and x to the fourth reduced to x to the third on the bottom. So the domain here is x not equal to 0, because we can't have the denominator equal 0, and 0 replacing x would cause the denominator to become 0. And we're not allowed to divide by 0, so the domain is x values that are not equal to 0. So anything but 0. Composition of functions. This is where we are taking the function of a function. Now, normally, when I write out f of x, I put an x in these spots. Now, if I were saying f of 5, I'd replace the x with a 5 anywhere there's an x in the problem. So in this case, f is the outside function, so that's the one I'm going to write out. 2 times what x is squared, plus 6 times what x is, plus 1. Now, we're replacing the x in f of x with the function g of x, which is this. So wherever there was an x here, I'm replacing it with this expression. 2x plus 5, 2x plus 5. Now, many of you have seen this before, but if you had a plus b squared, we know that's a plus b times a plus b. Well, there is a shorthand way of distributing that, and that is the first term squared, a squared, plus 2 times a times b plus b squared. So I can do a shorthand way of squaring that, and I'm going to do that with this. I'll do the multiplication distribution on the outside after I do the squaring. Now, 2x squared is 4x to the second. A times b times 2. 2 times 2 is 4. X times 5 is 20x. And 5, the b squared, is 25. distribute, I'll distribute the 2, so that's 8x squared plus 40x plus 50. I'll distribute the 6 plus 12x plus 30, and then the plus 1. When I combine my like terms, I get 8x squared plus 40 and 12 is 52x. 50 and 30 and 1 is 81. And that is f of g of x. I'm going to erase this so that I have room to work. Now, before I continue, you do sometimes see f of g of x written in this way. That's f composition g of x. That's what that little circle means. Now, a lot of people like to call it fog, and if the g is first, goff, all right? It's f composition g of x, which is the same thing as this. All right. See if you can do g of f of x. Remember, f of x is 2x squared plus 6x plus 1. G of x is 2x plus 5. See if you can follow the example and do g of f of x. Now that you've unpaused it, we're going to take g of x, 2 times x plus 5, and we're going to fill the g function with f of x, which is 2x squared plus 6x plus 1. So I'm going to distribute 4x squared plus 12x plus 2 plus my 5. And then I'm going to combine like terms, 4x squared plus 12x plus 7. And that's your answer. There you have g of f of x. Again, if it's a polynomial function, the answer is going to be for domain all real numbers. What about g of x? Well, I can take the outside g of x, 2 times x plus 5, fill it with the g of x inside, 2x plus 5, and all I have to do is distribute and simplify. So that would be 4x plus 10 plus 5, or 4x plus 15. All right. Of course, there's always the f of x, which I will do out for you now, just to show you how it's done. It is going to take a little bit of effort. So if you don't want to see this one done out, just move the slider along on YouTube and you don't have to watch it. But here is f of x, 2 times squared plus 6 times plus 1. I have to do some work on the side here. 2x squared plus 6x plus 1. 2x squared plus 6x plus 1. All right, so 2x squared plus 6x plus 1 times 2x squared plus 6x plus 1. Now I can't just simply do a formula here, so I'm going to multiply 4x to the 4th plus 12x to the 3rd plus 2x to the 2nd. Now I've used up this one, so I'm going to go on to the 6x plus 12x to the 3rd plus 36x squared plus 6x. And then on the end, I'm distributing the 1, which really just repeats what's in the second parenthesis, plus 2x squared plus 6x plus 1. I have to add this all up. 4x to the fourth plus, I've got a 12x to the third, a 12x to the third. So that's 24x to the third. I have a 2x squared and a 36x squared and a 2x squared. So that'd be 40x squared. And then I have a 6x, and a 6x is 12x. And 1. So let me write that in. 2 times, let's see, 4x to the fourth plus 24x to the third plus 40x squared plus 12x plus 1. Oops. Plus 6 times plus 1. Let's fill that in. 2x squared plus 6x plus 1. All right, I'm going to have to get rid of this so I have room to work. There we go. I'm going to distribute 8x to the 4 plus 48, excuse me, 48x to the third plus 80x squared plus 24x plus 2 plus, distribute here, 12x squared plus 36x plus 6 plus 1. Combine like terms, f of x, 8x to the 4 plus 48x to the third. I've got 80 and 12x squared, so that's 92x squared. 24 and 36 is 60x. And 2, 6, and 1 make 9. And there's your answer when you have a trinomial function of composition of trinomial function. All right. Did I add anything further down? No. Okay, here we go. Evaluating a composition of functions. This is really, let me just extend that so I have a little more room here. This is really just two separate problems being done. First, I'm going to find the value of f of 6. Well, here's f of x. So I'm going to take the 4 squared, minus, and I'm going to fill it in with 6 and simplify. We know 4 times 36, and 4 times 36, 144? 144. And 144 minus 6 is 138. So there's f of 6, 138. We're going to go up here and say g of 138. Because we're replacing the f of 6 with the value of it, which is 138. Now g of x in this case is negative 3 times plus 7, and we're going to fill it in with 138. So when I multiply, I get negative 414 plus 7, or negative 407. So g of f of 6 is negative 407. That's how you do evaluating a composition of functions. Now I could do the same thing with this one, and I suggest you give it a try. All right, now that you've unpaused the video, let's try it. First thing we start is g of negative 2. Now we know g of x was, whoa, come on, behave. G of x was negative 3x plus 7. And we're filling it in with negative 2. So negative 3 times negative 2 is 6, plus 7 is 13. So up here, I'm going to say f of 13. Now, f of x was 4 times x squared minus x. We're filling it in with 13. Well, 13 squared is 169. And multiply that by 4, I get 676 minus 13. So that would be 663 for my answer. So f of g of negative 2 is 663. All right, you give these two a try, f of g of negative 2 and g of f of 3, and see how you do. Now that you've unpaused it, let's do these. First of all, let's see. Now it's all 1, so I'll have to move that up a little. Let's see. G of negative 2, let's see, 1 over of 2 times negative 2, it's going to be 1 over negative 4. So over here I'm going to say f of negative 1/4 is 5 times negative 1/4 minus 9. Negative 5/4 minus 9. Now 5/4 is 1 and 1/4, and if it's negative and 9 is negative, that's negative 10 and 1/4. Or you might even have said that that was, let's see, negative 41 over 4. Either one of these answers would be fine for final answer. Now let's look at this one. F of 3, 5 times 3 minus 9. So 15 minus 9, 6. So I go back up here, g of 6, 1 over 2 times 6, 1 over 12. So g of f of 3 is 1/12. I believe that's it for today. So hope this all was clear to everyone. Have a great day.